As you may have seen in a previous video, constant velocity means you're not accelerating. That is, you're not speeding up, you're not slowing down, and you're not changing direction. In this video, we'll look at constant velocity and see how force affects it. It's an important relationship there. First, there are two kinds of constant velocity. First, you can have an object moving at a constant speed, say 20 meters per second, and in a straight line, just like that car. Straight line, not changing direction, and not changing speed, that's constant velocity. Here Whittler has just walked. In baseball, he's gotten 4 balls. Now he's walking straight down this line to first base bag, constant 4 meters per second, and as you can see, he's going in a straight line, no change in direction. He is exhibiting constant velocity. The other one is a little less obvious, but it's just sitting still, stationary. This guy's velocity is 0 meters per second, that's not changing. And now obviously his direction is not changing. So two kinds of stationary, two kinds of constant velocity. All right, now Newton's second law says force causes acceleration. Where I want to look at another way of looking at that, and that is to say, if there's no force, no acceleration. Force causes acceleration, and if there is no force, there is no acceleration. Let's look here. This boy's stationary. What will happen to this stationary boy if no force is exerted on him? Well, not too complex. He won't accelerate. That means he'll remain stationary, won't he? Yes. Now this next one, that's obvious. This one is not quite as obvious. Pay attention. Now we have a girl. She's walking to the right at 6 meters per second, a constant 6. What will happen to her velocity if there's no force? What will happen to this moving girl if no force is exerted on her? What do you think? Again, she won't accelerate just like the boy. That means she'll continue to move at the same speed, same direction. She's not going to speed up from 6. She's not going to slow down from 6. And she's not going to change direction. So, it's interesting, huh? An object moving forward at a certain velocity, constant velocity, no force, that object will continue to move in a straight line with that velocity on it. Yeah. Here's a classic example. Here we have Mark, who's already going 8 meters per second. And then Phil pushes on him with 20 newtons. But this is how we draw friction, right? Friction with the ground. It's pushing back with 20. Phil's pushing 20, and the friction's pushing back. And he's already going 8. Question. Phil pushes Mark as shown for 30 seconds. What will Mark's velocity be after that time? Do those cancel out, that 20 and that 20? What do you think the answer is? The answer is he's going to continue going at 8 meters per second. Because even though there are forces on him, that net force is 0 newtons, isn't it? It's the same as saying there's no force. So there is no force, no acceleration, constant velocity. So a moving object, if it has no force, or if the force is balanced to 0, it's going to stay at the same velocity, isn't it? Same direction. Well, that's it. The moral of the story then is that if no net force is exerted on an object, a 0 net force, the object's motion will not change. Now, if he's a stationary object, he'll remain stationary. If he's moving, the lack of force will cause him to continue moving, same speed, same direction. There's your video code.